Physics. I'm Mr. McConnelly, and today we're going to do a problem where we have a truck parked on a ramp. Now we've been dealing with vectors here, and this is just the next step in vector problems. So in this particular situation, I've drawn myself a hill, or a ramp, and here in Bern, we have a lot of hills. And it's common that you might stop your truck on a hill. Now if you stop your truck on a hill, here's my truck, which I'm going to draw stopped on the hill. You know, you gotta be detailed in your truck drawings. It's important. It's a lesson. Okay, so bed liner in there too. All right, so we got some running boards. Okay, so now we got our truck parked on the hill. It was important to get that correct. And if you park your truck on the hill and then for some reason something fails, like you forgot to put it in park, or you, I don't know, you have a standard transmission and the parking brake fails, and you don't have it in gear, it's in neutral, the truck might roll away. You know that. Well, what are all the forces acting on the truck? And specifically, how much force is going to pull it down the hill? That's what I'm kind of interested in here. So let's start by drawing our forces. The force of gravity always points, everyone, straight down. And now that you're on a hill, it's important for you to draw this such that, I'm drawing it pretty long on purpose because it's just going to help you see it a little bit better. Notice that my force of gravity is straight down, Fg is straight down, and therefore it will be perpendicular, right here, it will be perpendicular to the actual level ground. If there were level ground, then your force of gravity would be perpendicular to it, but since you're on a hill, it's actually a little crooked in respect to the truck. Okay, fine. What other forces do we have? Well, the other one that always was equal and opposite was called the normal force. Well, here's the problem. The normal force is always perpendicular to the ground. So the normal force is actually going to be going this way now. Can you see the problem that this leaves you with? They don't cancel anymore. Oh, how sad. Now, with this situation here, if this truck were to really roll away, which way would it roll? Down the hill. So which direction would the friction be? Uphill. Okay? So if I was going to draw the force of friction, it would be this way. Now really, if you just stop here, that's really all that's going on. Okay, that's all the forces. But what I'm going to do is something that is a kind of a continuation of what we've already started, is I want to know what are the components, or what are the two right angle forces that make up the force of gravity, because one of them is responsible for pulling me down the hill. You see what I'm saying? This force is pulling straight down, but ultimately this force of gravity really is pulling me down the hill. So how do I do that? Well, here's how you draw it. First of all, you got to kind of envision this a little bit ahead of time, and for some people that have trouble with visualization, you almost need to think of it like this. If this is the flat ground, see I'm using my folder to show not the flat ground, the hill ground, this is the hill, then I need to draw this such that the hill is going to line up and hit my force of gravity. You see what I'm drawing here, or what I'm trying to show you with the folder? So I need to have it like this. I need to have this force come down far enough so that when I draw this force, these two will meet at 90 degrees. Do you see how I pulled that trick off? It's a little bit hard for some people to visualize, so sometimes you got to use something that's square to kind of square it up for you. Now these two green arrows that I've drawn have simple names. The one that is parallel to the hill is called the force with two lines, which means a math parallel, force parallel. The one that is perpendicular to the hill is called the force perpendicular. That doesn't seem too hard. So if I wanted to solve for those, I got to give you a little bit of information here. First of all, let's put a number to the truck. Let's say the truck is 13,200 newtons. And I told you that the truck is on a 30-degree incline. Now, here's another thing you got to visualize a little bit, and maybe your math skills and geometry will help you out. If you look at the big triangle, like the hill triangle, okay? See that big black hill triangle? And you compare it to the green triangle here, those are similar triangles, okay? And if you kind of start like matching, like this matches to that, and this force of gravity actually matches the hypotenuse, so those are the hypotenuses, and you start moving things around, you'll realize that that 30-degree angle actually appears where on this triangle? Down here, most people are pointing to it. So now you have yourself a situation that you can solve. So let's do it. If you're trying to solve for the force perpendicular, we'll make that the first one we're looking at, then we're going to use the idea that this is the adjacent side compared to the angle, and that's the hypotenuse. So I'm going to use the cosine concept. Cosine of theta is adjacent over hypotenuse. So the cosine of 30 degrees is the adjacent side, the one I'm looking for, over the hypotenuse, 13,200 newtons. So is anyone following along quick enough to get that number for me? Got something like 11,400?
Yep.
Good. 11,431 is, I think, what came up on my calculations. So this is how much force is pulling the truck down into the ground. If you're parked on a hill and your truck weighs 13,200 newtons, only 11,400 is actually pushing down on the road. Where's the rest of it going? The rest of it's trying to pull you down the hill, so let's figure out that one, because that one seems more interesting. So, the force parallel to the hill, notice that's the opposite over hypotenuse, that's going to be sine. So the sine of 30 degrees, which is one of those nifty ones that's easy to remember because it's 1/2, is the opposite one, of course, parallel, over 13,200 newtons. And so all I got to do is in my head cut 13,200 in half, which is going to be about 6,600, isn't it?
Yep.
So there's 6,600 newtons pulling you down the hill. No wonder you roll down the hill. So for today, that's our force on a hill physics.